Hey guys, Mr. Backerberg here. In this video we're going to take a look at asymptotes. So what I want you to do is, in your calculator, I want to type in the equation y equals 2x squared over 4 minus x squared. When we do that and we hit our graph button, we're going to get the picture that shows up on the right hand side of the screen here. As we're looking at the picture of this graph, it's got some weird behavior happening. As we work our way out to the right-hand side and as we work our way out to the left-hand side, this graph is starting to flatten out around that y value of -2. That line that just showed up that I just put on the screen at y equals -2 is a horizontal asymptote because of the behavior that our graph is displaying around that specific y value. Now also, as we look at the graph towards the middle, we've got kind of this U-shaped portion of our graph, and as we work our way to the right towards this x value of 2, this graph increases pretty rapidly. And same thing happens as we move to the left towards -2, our graph is increasing pretty rapidly. And if we look at these pieces down on the bottom, as we're approaching -2 from the left-hand side, our graph is heading straight down, and as we approach +2 from the right-hand side, our graph is heading straight down. So at x values of +2 and at -2, those would be vertical asymptotes for our graph. So we're going to look at a more formal definition as to what a horizontal asymptote is. So the line y equals b is a horizontal asymptote for the graph of our function y equals f of x if our function values, if our y values, approach a limit of b as x approaches positive infinity or negative infinity. So what that means is that our graph is approaching a specific b value, a specific number, as we work our way out to the right towards positive infinity and as we work our way to the left towards negative infinity. And we can actually write this out in something called limit notation. And limit notation is going to show up as we start working towards more calculus type ideas. So what we would say is that the limit of our function f of x is equal to this b value as our x value approaches negative infinity. But we could also write this for our x value approaching positive infinity. So we can say that the limit of our f of x function is equal to that same b value as our x values approach positive infinity. Now we've also got a more formal definition of our vertical asymptotes as well. So the line x equals a in an x equals equation is a vertical line equation. So the line x equals a is a vertical asymptote of our graph for our function y equals f of x if our function values, if our y values approach a limit of either positive infinity or negative infinity as we approach a specific x value from either direction. And we can also write this out in limit notation, so we can say that the limit of our function f of x is equal to either positive or negative infinity as our x values approach a from the left-hand side. That little negative on the a means from the left-hand side. And we can also approach a from the right-hand side, and the same thing would happen. So the limit of our function f of x is equal to either positive infinity or negative infinity as our x values approach a from the right-hand side. And a little plus sign on our a means from the right-hand side. So we're going to look at the graph for the equation y equals x over x squared minus x minus 2. But before we actually look at the graph, I want to take a look at the denominator, because anytime we're dealing with a fraction, we need to make sure that the denominator is not equal to 0. If we look at factoring out the denominator down here, this x squared minus x minus 2 is going to factor into x minus 2 and x plus 1. And if we think about the domain of this function, we would not want the stuff on the bottom to be equal to 0. So what we can do is we can take that x minus 2 and say we don't want it to equal 0, but we can do the same thing with the x plus 1. We also don't want that to equal 0. So here we don't want x to be positive 2, and we don't want x to be negative 1. Because we have values that we're excluding from the domain of our function, those are really good candidates for where vertical asymptotes are going to happen. And if we're kind of informally finding horizontal asymptotes as well, we can look at this fraction as a whole, and as these x values get really big, we would be taking a big number x and dividing it by the product of two other big numbers. So what's going to happen here is if you take a number and divide it by a really, really big number, you're going to keep getting smaller and smaller decimals. So your decimals are going to keep getting closer to 0. So I'm going to guess that we're going to have a horizontal asymptote around y equals 0. So to confirm these, we're going to type this into our calculator and take a look. So there's my equation typed in. I'm going to hit my graph button. Now, like I said, we had domain issues at -1 and also at +2. So those were good candidates for where our vertical asymptotes were going to happen. So if we look at an x value of -1, what we've got happening is as we approach that x value from the left-hand side, our graph is heading down to -infinity. And as we approach that x value from the right-hand side, our graph is heading up towards +infinity. So because our picture is displaying that behavior, that does mean that we have a vertical asymptote at -1. And as we look at our x value of +2, we've got the same thing happening. As we approach from the left-hand side, our graph is heading down to -infinity. And as we approach from the right-hand side, our graph is heading up towards +infinity. So those are our vertical asymptotes. Now, as we look at what's happening on the far ends of our graph, as we go out towards +infinity to the right-hand side, our graph is getting really, really close to that x-axis, meaning a y value of 0. And same thing is happening on the left-hand side. As we head out towards -infinity, our graph is again getting really, really close to that x-axis. So because our graph is displaying that behavior on the ends, we can confirm that there is a horizontal asymptote at y equals 0. That's going to be it for this video. Thanks for watching.